Okay, I'm going to make some general comments about this graph. It's for exercises 5 through 10. It also has a function for it. Okay, problem 5 through 10. Here's the function down below here. It's a piecewise. I'm just going to make some comments, and then you can answer the question. So, for a function to be continuous, when you draw the graph, the pencil has to stay on the paper the whole time. If you have to lift it off to draw it, then it's not continuous. So you can pretty much see that right at 0 it's discontinuous because it's not connected. At 1 it's discontinuous. You draw up here, lift the pencil, draw the dot, and then make a hole, and then go down. And there's 2 more holes on the ends here. So it's discontinuous to lots of locations from a visual point of view. The definition of continuity is this. The limit as x approaches c of f of x exists. It exists. So there is a limit. The limit has to exist. The function value has to exist. 1, 2, and thirdly, the limit has to equal the function value. So, for example, look at 1 up here. Does the limit of 1 work? So if I take the limit as x approaches 1, do I get an answer? Well, as I approach 1 from the right, it goes up to 2. As I approach 1 from the left, it goes up to 2. So yeah, it equals 2. What's the function value at 1? The function value at 1 is 1. So does the function value equal the limit value? No, they're not equal. So the function value has to equal the limit value to be continuous. So it's not continuous. So you've got to be checking these things right here on all these problems. Most of these problems. There's some and not, but most of you will. Now I could have used the function, the piecewise over here to done the same thing. But to do the limit as x approaches 1, I would have had to do it piecewise. Approach it from the right, approach it from the left. So this limit technically would have to be done in 2 pieces. 1 from the right, and the limit as x approaches 1 from the left. So from the right side, you're bigger than 1. So what piece is just a little bit bigger than 1? Probably, whoops, I made a mistake. That shouldn't be there. Okay, so bigger than 1 would be actually this piece right here. This is the 4th one down. X greater than 1, that's just a little bit bigger than 1, getting close to 1. So the bigger than 1 would be that one. The limit as x approaches 1 from the right would be minus 2x plus 4. Plug in 1, you get minus 2 plus 4 gives you 2. This limit as x approaches 1 on the left, a little bit less than 1. Here's x less than 1. That's a little bit less than 1. You get 2x. Plug 1 in there. 2 times 1 give you 2. So both answers are 2. Hence the limit is 2. That's how you'd have to do it if you did not have a graph. So limits can be tricky. Sometimes they require 2 pieces. Quite often when you see a piecewise function, to do a limit, you got to break it into 2 pieces, a right and a left. So there's some general comments about those problems. See if that'll help you out to solve that one.